Hello and welcome. I am Dr. Pauline Fu. In this video, I will present distribution of sample mean. So there are two situations for distribution of sample mean. The first is describe the distribution of sample mean when you have a normal population. The second situation, describe the distribution of sample mean when you have non-normal population. Okay. Remember, we have for the sample, the characteristics of sample, we use statistic, such as sample mean X bar. These statistics are random variables because their value varies from sample to sample. Okay. So if I randomly select 5 students from 100 students, the average mark of these 5 students is different from the other 5 students, different sample. Okay. So they have a probability distributions associated with them. In this session, we'll focus on the shape, the center, and the spread of statistics, such as the mean. That's why the title of this video is Distribution of Sample Mean. The sampling distribution of a statistic is a probability distribution for all possible values of statistic computed from a sample size of n. Okay, so sample distribution for all random samples from population. The sampling distribution of the sample mean X bar is the probability distribution of all possible values of the random variable X bar computed from a sample size n from a population with mean is mu, standard deviation sigma. So imagine you have a population. The population mean is mu. Population standard deviation is sigma. You want to take a sample from this population, size of n. And then you want to take another sample from the same population, sample size is n. Okay, so you keep on going until you take all possible samples of size n from the same population. And then you study those sample mean, the distribution of all sample means you get. So there are some steps to follow. Step 1, obtain a simple random sample of size n. Step 2, compute the sample mean. Remember, you have many sample size of n in step 1. And in step 2, you have many mean. They all refer to sample mean. Different sample, you get a different mean. Okay. Step 3, assuming that we are sampling from a finite population. You repeat step 1 and 2 until all distinct random sample of size n have obtained. So let's look at an example. Sampling distribution of the sample mean if the population is normally distributed. The weight of pennies minted after 1982 are normally distributed with the mean 2.46 grams and standard deviation 0.02 grams. approximate the sampling distribution of the sample mean by obtaining 200 simple random samples of size 5 from this population. So imagine you have many pennies. So now you want to take sample size of 5 and then calculate the average of this sample size of 5. After that, you repeat yourself 200 times. So each time you take 5 samples. Okay, you take 5 pennies, take an average. Another time, take another 5 pennies, take the average. Keep on going until you do 200 times. So the data is on the following slide, represent the sample mean for 200 simple random sample. Sample size is 5. Okay. So let's take a look at the example. This data, you have 200 data here, 200 data. What each data represent? For example, the first data, 2.444, what does it mean? Means you take 5 pennies. You take the average of these 5 pennies. The result is 2.444. So the second data, 2.483 means you take another 5 pennies. Then you do the average of those 5 pennies. The result is 2.483. You keep on going. So each time you take 5 pennies, calculate the average. And those are all the numbers. Total 200 of them. 200 of them. Okay. So now you have 200 numbers. Each number is an average. Now you take the average of these 200 numbers. The average of these 200 numbers. And you get this, you may get a number, okay? We'll talk about more about that average of average. Okay? So actually this slide explains how did you get 2.444? How did you get the first number 2.444? You take 5 pennies and then you do the average of these 5 numbers. You get 2.444. Similarly, you get another 5 pennies, then take the average. You may get this second number, 2.483. Okay. So the mean of those 200 sample means is 2.46. So if you take the mean of these 200 numbers, remember we have 200 numbers here. From here to here, there are 200 numbers. You add all these 200 numbers divided by 200, and you get the mean value, 2.46. Okay. And this number is the same as population mean. How do we know? Because we already know the population mean. Okay, see here. The weight of pennies minted after 1982 are approximately normally distributed with mean 2.46. Okay, this is based on the past studies. We know the population mean. And we verify that this sampling mean, the mean of those 200 numbers, also 2.46. Is this coincident? No. Okay. And also we can figure out the standard deviation of the sample mean. Means you calculate standard deviation for these 200 numbers. Standard deviation for these 200 numbers, okay? And you'll get this number here, 0.0086. This number is smaller than population standard deviation. How do we know? Here it is given, okay? Population standard deviation is 0.02. Okay, and our sample standard deviation 0.0086. Of course, sample standard deviation smaller than population standard deviation. All right. So if you construct a histogram for those 200 data, histogram, you are going to get this layout. Okay, and it is a roughly bell-shaped symmetry. Okay, so this is a 200 samples. Suppose you take 500. Okay, you repeat yourself 500 times. Each time you pick 5 pennies. You calculate the average. You repeat yourself 500. What happened for the histogram, it will be more closer to the normal distribution. And the standard deviation will also be decreased when you increase the sample size. Okay, standard deviation will be decreased. But the sampling mean will remain the same, 2.46. So this example, we are going to study the impact of sample size on sampling variability. Approximate the sampling distribution of the sample mean by obtaining 200 simple random samples of a sample size n equal to 20 from population of weights of pennies minted after 1982. Remember, the mean distribution for the pennies is normally distributed with the mean 2.46 grams and standard deviation 0.02 grams. Okay, in the previous example, we take sample size of 5. This time, I will take sample size of 20. Okay, 20 sample size of 20. And what do? You calculate the average of 20 pennies. Next time, you calculate the average of another 20 pennies. Still next time, you calculate the average of another 20 pennies. You repeat yourself 200 times. And what you are going to find, you are going to find the mean of those 200 numbers is still the same, 2.46. But the standard deviation becomes 0.0045 when you have sample size 20. Remember in the previous example, when you have sample size 5, the standard deviation 0.0086. So the standard deviation, there is less variability in the distribution of the sample mean when you have sample size 20 versus when you have sample size 5. So the bigger the sample size, the less variation, and the smaller the standard deviation. Now we are going to introduce the mean and the standard deviation of the sampling distribution of X bar. So I will explain what does this mean. Okay, use the first example. This example here, remember we are going to take sample size of 5. Each time we calculate the average of these 5 numbers. And I repeat myself 200 times. So I get 200 averages. It is here, 200 averages, okay? For this 200 data, you can calculate the average of these 200 data. That average is this title here. That average is the mean of the sampling distribution of X bar. Okay, the result is 2.46. The mean of the sampling distribution of X bar means the mean of those 200 numbers. The mean of those 200 numbers is the mean of the sampling distribution of X bar. Okay. Similarly, for those 200 numbers, you can calculate standard deviation. Okay, remember the standard deviation for those 200 numbers, when you have sample size 5, that is 0.0086. That 0.0086 is the standard deviation of the sampling distribution of X bar. Okay. Remember we did two situations, two examples. One example, sample size equal to 5. The other example, sample size equal to 20. Here, sample size equal to 20. In both situations, the mean is the same, 2.46, equal to population mean, but standard deviation is different. When you have sample size n equal to 5, the standard deviation is 0.086. And when you have sample size 20, the standard deviation is 0.0045. Okay, so we want to ask this question here. When you increase sample size, the mean will not increase. The mean will be the same. That is the population mean. But the standard deviation has been changed. When you increase sample size, standard deviation decreased. And what is the relationship between the sampling standard deviation of the sampling distribution with the population standard deviation? This is the relationship. Okay. You use the population standard deviation sigma, divide square root of sample size, you get standard deviation of sampling distribution. So in this formula, there are two sigma. One sigma is population standard deviation. The other sigma, we use sigma subscript X bar, that is the standard deviation of sampling distribution. And we call the standard deviation of the sampling distribution of X bar is the standard error of the mean. So what is the standard error of the mean? It is population standard deviation divided by square root of sample size. Okay. So that is, I'll try to emphasize what is standard error of the mean? Population standard deviation divide square root of sample size. That is the standard error of the mean. It is use sigma subscript X bar here. Okay. Too dark. So the shape of the sampling distribution of X bar if X is normal. So if a random variable X is normally distributed, the sampling distribution of the sample mean, it is also normally distributed. Okay, as we demonstrated here. If you take frequency distribution graph, histogram, it is sampling distributed. See, it is bell-shaped symmetry. Okay. So we are here. So next, let's take a look at another example. Describe the distribution of a sample mean. So the weight of pennies minted after 1982 are approximately normal distributed with mean 2.46 grams and standard deviation 0.02 grams. The question is, what is the probability that in a simple random sample of 10 pennies minted after 1982, we obtain a sample mean of at least 2.465 grams? So the question asks you, what is the probability that in a simple random sample of 10 pennies, okay, at least 2.465. So let's solve this question. Because we know X bar is normally distributed. Remember what is the X bar? X bar is the, here, is the mean of the sampling distribution. Use X bar, the mean of the sampling distribution. Okay, so the mean of the sampling distribution is normally distributed with the mean equal to population mean 2.46 and standard deviation of X bar, equal to population standard deviation 0.02 divided by sample size. Take square root of sample size. Sample size is 10 here. Given sample size is 10. Okay. So first we figure out what is the mean of the sampling distribution. The answer is 2.46. And we also calculated the mean, the standard deviation for sampling distribution. The answer is 0.0063. Okay. Once we get those two numbers, we can figure out what is the Z value for 2.465. Why we are interested in 2.465? Because the question asks you, what is the probability that in a simple random sample of 10 pennies, okay, the sample mean at least 2.465. So we need to translate 2.645 into Z value. Remember the formula, Z equal to X minus mu divided by sigma. Okay. So sigma is 0.0063, mu is 2.46. And you plug in, you get the Z value 0.79. And now go back to the question. The question asks, what is the probability? At least means greater. What is the probability? Z greater 0.79. Okay, actually before this step, you can write down what is the probability X greater 2.46, because that is the original question. What is the probability X greater 2.46? And this probability is the same as translate to the Z value. Z value greater than 0.79. Okay. When you draw the diagram, okay, using standard normal distribution. Remember, standard normal distribution means, I will redraw it. Standard normal distribution means mean is 0. Mean is 0. And the standard deviation is 1. Now you got a z value 0.79. If this z equal to 0, then 0.79 is here, 0.79. Okay. And the question asks you, what is the probability of greater than 0.79? So what is this area? Remember the interpretation of the area, it is the probability or proportion or percentile. Okay, so we are asked to figure out what is this area. Okay, when you have this point, 0.79. And we can use two methods. One, use Excel, and the other, we can use tables. Okay. So now let's use the Excel to figure out what is this area. Remember, either Excel or the table give you the result is the area to the left of the value. The area to the left. When you get the result from the table or from Excel, the number is the area to the left. And then you use 1 minus the area to the left. You get this, the area to the right. Okay. So let's pull out the Excel. And so we want to do so we want to figure out this area, but we have to figure out the area to the left. Okay, so equal, I will just increase the font size. Back. Nice weather today, very sunny. Not too hot, not, it's just perfect. Okay, so equal norm. So I try to find the area, norm dot dist distribution. Okay, x is 0.79. This is standard deviation. So mean is 0. Standard deviation is 1, and it is accumulative, yes. Okay. So you get this green area, okay, Control C, Control V. So this green area is 0.7852, but we want the area to the right, this red area. Okay. So you use 1 minus this number, you get the area to the right. Okay, so you get this number. Okay, so this is Excel method. Okay, the other way, you can use this diagram to use Excel. You are going to get the same number. Okay, so I'm going to demonstrate here. When you look at this diagram is the regular normal distribution. And this diagram, the red one, the one I did is the standard normal distribution. If you have the regular normal distribution, because it is said the population mean is 2.46, so this is 2.46. And the question asks you, what is the probability? See here, what is the probability of x greater than 2.46? This is 2.46. What is this probability? See this blue area. Okay. Again, to find the blue area, you need to find the area to the left. And how do you find the area to the left? You can use Excel. Okay. Look at this diagram. Okay. So equal norm dot dist. This time x you type in 2.465, and mean is 2.46. Standard deviation 0.78. 0.0063, 0.0063, that is the standard deviation. Accumulative, yes. Okay. See, you get the same number. Okay, so I will just copy down this formula to show you. This is the formula I get, okay? And the number is, the result is 0.7852. So this equal to 0.7852. Okay. Once you get this number, you use 1 minus this number, okay? So you get this number here. Oops. Use 1 minus this number, okay? You get this number here. Okay, so this number, this I should delete. So the red area should be this number. Okay, so this is try to use the same color, okay? So the red area is 0.214. Okay. So anyway, we get the answer. The probability of greater than 2.46 is 0.2147. Okay, so that is the Excel method. Now let's look at the table. If you use the table, you can only use standard normal distribution because the table is constructed based on mu is 0, standard deviation equal to 1. Okay, so you have to, based on this diagram, to look up into the table. So in this diagram, you are given Z value 0.79. So you go table, look up what is the area to the left of 0.79. Okay. So let me pull out the table. Where is my table? Okay, no tables. No. Yeah, formulas and tables. Okay, so this is the table. I'm going to erase the markers I made before so that it is all right. So in this table, we need to locate where is 0.79. So remember, you need the Z value have two parts, the first column and the first row. The first column represents 0.7. The first row represents 0.09. The combined together, 0.79. So locate 0.7, it is here, 0.7. Then on the top, locate 0.09. So the intersection part between 0.7 and 0.09, that is the area to the left of Z value. So the answer is 0.7852. It is the same as we get from Excel. Okay, so this is the table method. Go back. So I'm here. All right. So far, we assume the population is normally distributed. How about it is not normal distributed? What happened to the mean of the sampling distribution? So this, from this slide onward, it is about non-normal population. Non-normal population. Think about if you rolling a die. If you roll a die, you get either 1, 2, 3, 4, 5. because a die has 6 sides. The probability of seeing one, it is 1/6 when you roll a die. And the probability of seeing number 2, 1/6, etc. And the probability of seeing number 6 is 1/6. Okay. So now, based on this table, we see the distribution of this die. X represents the value on the face when you throw a die. It is 1 to 6. And Y represents the relative frequency here, relative frequency. Okay, so this is not normal distributed, obviously. Okay. For this non-normal population, we also want to investigate the mean of the sampling distribution. Okay. So this time I will try to use an Excel to do this. Estimate sampling distribution of X bar by obtaining 200 simple random sample of size 4, and then calculate the sample mean for each of the 200 samples. Okay, so I will stop here. If you can do sample size n equal to 4, you can do n equal to 10, n equal to 30. You can do n equal to any number. So I will just focus on sample size n equal to 4. Okay. All right. So Excel. Before we do Excel, repeat the question, what you are asked to do, okay? You want to get 200 simple random samples. Each simple random sample size is 4, okay? That is the question. So how do you use Excel to simulate this activity? So I'm going to do this one here. So I'm going to roll a die, okay? This roll a die, and then I will roll die 4 times so that I get sample size n equal to 4. So when I roll a die, try to increase the font size. And I need random number generator. So rand between, it is when I roll a die, the number is any number between 1 to 6. So rand between, okay. And I roll die 4 times so that I get sample size n equal to 4. This is when I roll a die 4 times, I get 1 random sample of sample size 4. But the question asks you to get 200 such sample. 200, what you do, you just use the fill handle to drag down until you see row 200. That is 200 simple random sample. And each simple random sample has a size 4. Oops, 197. So 2 more, yeah, 200. See, I get 200 simple random sample. I get 200. Wow, 200 simple random sample. And each sample is the sample size of 4. Okay, so I finished half of the task. Okay, it said obtain 200 simple random sample of size n equal to 4. I did that. I just did that. And now you are asked to calculate the sample mean for each of the 200 samples. Okay, so calculate sample mean for this sample, calculate sample mean for this sample, calculate sample mean for this sample until you did 200 times calculation. Because I'm using Excel, I will not do 200 times. I will just do one calculation and then I will copy down the formula, okay? So equal average. By the way, the mean in Excel is the average, okay? So equal average, okay? And then copy down the formula. See, I did 200 means. I did 200 mean, okay? And for those 200 mean, I finished this part here. I computed, I calculate sample mean for each 200 samples, okay? And then create histograms, okay, create histograms. So, I can go data on the menu bar, data analysis, select histogram and click OK. Input range, that is my input range. Input range, output new worksheets, click OK button. Oh, I forgot to click the graph. So where I am. It is here. So I will repeat myself, data, and then data analysis, histogram, output, chart output, select chart output. See, this is the histogram, it's not okay. It is this is 100 times. If you repeat 1,000 times, oops, you will probably get the normal distribution. So I'm just going to copy this, Control C, and paste it, oops, box, oops. Okay, so that I can make annotation. So this is the histogram frequency distribution. It is approximately normally distributed. As you can see, although the population is not normally distributed, but when we get the mean of the sampling distribution, it is normally distributed. Suppose usually sample size greater than 30, you will get a normal distribution. Okay. All right. So in summary, what we did in this lecture, we did two things. One, we described the mean of sampling distribution when the population is normal, bell-shaped symmetry. Second, we describe the mean of sampling distribution when the population is not normally distributed. Okay, and that's all for this lecture. Thank you so much for your time. Hope you learned something. Enjoy beautiful weather. See you next time.